today I'm going to be representing COM425 engineering project final report, which is machine learning approach to stress detection. I'm Fati Sezgin and my advisor is beloved assistant Professor Dr. Peri Güneş. The representation consists of 8 chapters, which are introductions, purpose of the study, literature review, STEM analysis and design, diagrams, recommendation, conclusion, and references. It's established that drivers are adversely affected by the effects of anxiety, which leads to traffic violations or injuries. Related studies indicate that drivers encounter acute stress primarily because of the road conditions, density of traffic, social interactions, unpredictable circumstances and behaviors, time scale, impacts on and urban planning issues. A realistic method of evaluating the level of mental stress of an automotive driver includes measuring psychological conditions. The driver's stress can be assessed by recording the amount of blood sugar, respiration rates, heartbeat, blood pressure, and muscle activity. The physical sensors used to digitize the following effects are electrocardiogram, electroencephalography, galvanic skin response, electromyogram, and respiration. Electrocardiogram is a basic procedure that can be used to monitor the rhythm and electrical activity of the heart. Sensors attached to the skin are used to perceive electrical signals produced by heart every time it beats. Electroencephalography tracks voltage changes arising from ion current between brain neurons. Scientifically, EEG refers to the recording of random electrical stimulation of the brain over a span of time, as recorded from several electrodes mounted on the scalp. Diagnostic applications typically rely either on event-related potentials or on spectral EEG material. Galvanic skin response originates from the automatic activation of sweat glands in the skin. Emotional stimulation is the reason for the sweating of the hands and feet. If we feel emotional, the GSR statistics display distinct patterns, which can be objectively measured by the visual inspection. Electromyography is a medical technique that measures the health of the muscles and nerve cells that monitor and control them. These nerve cells are referred to as motor neurons. They rely on electrical signals, which allow muscles to contract and relax. The EMG transforms these impulses into plots or numbers with the assistance of a device called an electromyograph. Respiration refers to the breathing of a person and air movement in out of the lungs. The breathing system delivers oxygen to body tissues in order to preserve acid-base equilibrium by eliminating the waste product of carbon dioxide. Breathing has a rhythm that typically is normal. A normal rhythm ensures that the breathing frequency is equal to the breathing rate at the same intervals. The aim of the study is create an easily optimized machine learning model with accuracy above a certain rate. This study will benefit for the students wishing to gain experience in machine learning classification problems and people with experience in machine learning but want to redecorate themselves. Stress has always been a part of our life, which disrupt health conditions of human beings. Despite its role in our lives, stress detection has challenges. According to the reference tree, the authors have used various biological data such as respiration, galvanic skin response, hand and both hand and foot, heart rate and EMG from various subjects in different circumstances and places while they were driving. For feature selection, a software called VICA and support vector machine algorithm has been used. For the stress detection part, extracted and selected features have been used for the different classification algorithms such as support vector machine and k-nearest neighbor. According to the reference for speech and GSR signals are used, trier, social stress test, and mental challenge for stress interaction stimuli. With 4 different techniques, K-mean classification, decision tree classification, Gaussian mixture model has been shown well. Although GSR features were enough to detect stress at most 70% with spot vector machine providing 92% of accuracy rate. Also, Jennifer A. Haley and Rosalind Pickard, reference 5, recorded and analyzed psychological signals like electrocardiography, EMG, GSR, foot and hand and respiration during real-world driver tasks, which have been collected in 3 different areas. They end up with 22 features from 5 signals and have used linear discriminant function to classify the stress level. To summary, used sensors, feature extraction method, feature selection methods, and stress detection algorithms, if it exists, list in the table. To begin with, implementing a machine learning environment for stress detection should be planned as well as any other studies. In line with this target, the phases of the project, what kind of tools or resources will be needed to show should be declared. Simply, what and how questions should be enlightened. Data for training has been obtained from stress recognition in automobile drivers database in FISONet databank. This dataset contributed uh, within the data which is taken various psychological sensors, signals and features while they were been driving through the streets and highways around Boston. Features related to heart rate, skin conductivity, electromuscular activity, and respiration. For distinguish rest from activity, relevant sensors have been around in figure 1. The signals and the frequencies can be seen in the figure 2. Figure 3, the 10 seconds of sampling has been collected in FISONet website to demonstrate the different biosignals waveform details about driver number 5. The table shows the metadata about the recordings such as the driver name, sampling frequency, signal length in minute, number of signals that has been collected and the collected signals names. Also in the table, the recordings that has missing information marked as red, indicating the missing features. The drivers 1 through 4 and driver 13 and 14 has lack of signals, and the driver 17A and 17B recordings is not complete is not complete for sampling length. Class diagram. Purpose of the class diagrams is showing the system's classes, operations, attributes, and relations between objects. Signals attribute, list of numpy array of numpy array. In addition, all the driver signal information will be kept into the signals list. Fields, list of dictionary type that includes acknowledges about the driver sensors. It consists of signal frequency, signal length, units of the signal, signal names, and comment section. All signals, list of signals for all drivers, metadata, list of fields for all drivers, kernel, type of string that indicates that which kernel should be used for the algorithm, data frame, type of pandas data frame for plotting drivers information, time intervals, type of pandas data frame for plotting time intervals for the driver includes initial rest, st1, highway 1, st2, highway 2, st3, final rest. For the component diagram separates the systems into different levels of functions. Component represents independent subsystems under the system. First, in the data component, the data will be processed, then processed signals and metadata will be given as inputs to the support vector machine component. In the same way as data has processed in the data component, support vector machine manipulates the data in order to make prediction. After the prediction has taken place to variable x, which represents the pandas data frame, and the y prediction, which represents the prediction label, will be passed to the visualization component. Finally, in the visualization component is responsible for the plotting operations corresponds to the given inputs. Deployment diagrams are used to visualization of how the different hardware components, software components are connected. As a result of the deployment diagram, which components depends on which artifacts in the environment of Python 3.5, 3.8 are constructed. Data component should import the OS package for reading the files in the dataset. In the same way, VFWB package are used for the converting the data into signals. Visualization component relies on the matplotlib library, which is a popular Python library that handles the plotting operations. Lastly, the support vector machine component relies on the NumPy package for the handle of signals and the pandas library for plotting the features into data frames. Recommendation, as I mentioned before in the purpose of the study section in presentation, this study can benefit for students who want to learn about machine learning problems and who plans the psychological studies in the medical field. experienced computer students, but who want to rebuild themselves. If we conclude the research study, a high degree of accuracy can be obtained by training the various biosignals to be taken from the human body in the best way to detect stress. In this case, it is important that the features selected are linked to stress. That is to say, care should be taken while extracting and selecting features. All these features allow the preparation, optimization, and deployment of a machine learning model with high accuracy rate. These are my references, and thank you for listening to me.